Okay, we've got one of these questions where we have to consider all the forces on the object. Okay, this particular object is being held in equilibrium, so we know therefore that the resultant force in any direction is going to be zero. But we need to start with a really good force diagram with all the forces on. So we've got a force of F in this direction. We don't by choice put on units on force diagrams because they are confusing. That N is a unit, not an actual magnitude of a force. So what other forces will be acting on it? Well, we always, potentially, with an object under gravity, have the weight of that object. And this object has got a mass of 2, so mass times g is the weight, so this is going to be a 2g force downwards. And the other thing that's touching it is the string. Okay, so the string can exert a force on it, but strings are only allowed to exert a tension force acting along the string, so we'll call that T. And is there anything else that is touching the object? No. The weight is the only force that can be exerted on the object, except by something that's touching it. So we've got these three forces in equilibrium, so we are going to resolve, and the resultant is going to be zero in any direction we choose. Now, one way to resolve would be to resolve horizontally and vertically, which is perfectly possible, but both of the unknown forces will need resolving then. There'll be cosines and sines of 30 all over the place. So we should consider, especially due to the fact that if we actually work out some angles here, if I were to draw on the vertical here, then I've got some Z angles. What do you call those? Alternate angles. So this would be 30 degrees as well, and this clearly will be 60 degrees because 30 plus this one will make this right angle. So 30 plus 60 degrees means that this is 90 degrees. So there's a 90-degree angle between T and F, which really I'm going to think that we've got basically our two directions to resolve are this way and this way. So I could call this X and I could call this Y and use column vectors, or we could just say parallel and perpendicular to F. So if we do that, then if we do the forces parallel to F, then we've got F acting this way, and then we've got a component of the 2g acting that way. So I've got to find an angle to use with the 2g. Well, if I extend the line of the string backwards, this is where maybe I've compromised by having too small a diagram. So if the t is acting this way along the string, and here's my 2g acting downwards, and I extend this dotted line backwards, then we agreed that that was an angle of 30 degrees, so this is going to be 30 degrees here. So I've found an angle that 2g makes with the directions I'm resolving in. So I'm resolving this way at the moment, okay? So the two components of 2g, when I resolve in this direction, along the line of t, then I'll have the one that cuddles up to that direction, that will have the cos. So the one I'm doing now, the one that's parallel to F, I'm going to have, with forces parallel to F, I'm going to have F, okay, and then in the opposite direction I'm going to have minus 2g, and it doesn't get the cos, so this is going to be cos, it's going to sine of the 30 degrees. And that's going to equal 0 because it is in equilibrium, and therefore F is going to equal 2g times sine of 30 degrees, which we can work out, taking g to be 9.8, F is going to equal actually 9.8 newtons. Okay, so I can put in units now. All right, and then if I go perpendicular to F, well, T is perpendicular to F, so I'm going to have T, if I take that direction, to be positive, and then 2g will have a component in this direction, and this one, the cos, the angle does cuddle up to this direction, so it's going to be minus 2g times cos of 30 degrees, and that's going to equal 0, so that's going to give me that t equals 2g cos of 30 degrees, which my calculator can tell me, and that is... Well, my calculator is giving me this thing in terms of root 3. If I give that as my answer, it'll be marked wrong because this is an exact answer, which is not appropriate when we've used g as 9.8. We need the decimal version of that. So 69.97, we've got to round to either 2 or 3 significant figures. So we're going to round that to 17.0 newtons. That's what t is, and we are done. That's our complete solution.